In this example, we're going to be sketching the parent function for a rational function. So this graph is going to look kind of something like this. And we're going to need to do a little bit of legwork here. We're going to need to plot a number of values. So let's do f of x, and it's going to be 1 over x. A ratio here, fraction. And then we're specifically with a rational, we're talking about values of x that are going to be in, or x that's going to be in the denominator here. And this is the simplest form. You just have 1 over x. There's not a 2 or an 8 here or a negative sign or anything like that. So let's just graph this, and we're going to have to do a number of points. So we'll try to make this table a little bit longer here. And I'm going to choose some values like -2, -1, -1/2, -1 over 4, 0. We'll do 1/4, 1/2, 1, and 2. Alright, we'll move this up just a touch so you can see that there. There we go. Okay, so f at -2 is going to be 1 over -2, which is just -1/2. F at -1 will be, let's see here, -1, right? Just 1 over -1. This one's a little tricky. F at -1/2 will be 1 over -1/2. We multiply by the reciprocal here, so that's actually -2. This one's going to be -4 then. And this would be, this is a fun one. So f at 0 is 1 over 0, and this is undefined. So that point does not exist. 0 is not possible for the domain here. That causes the function to be 0. F at 1/4 would be 1 over 1/4, which is 4. This value, 1 over 1/2, would be 2. 1 over 1 is 1, and 1 over 2 is 1/2. If you substitute that in here. So let's plot these. We've got -2, -1/2. It's right there. -1, -1. That's here. -1/2 here, and then down 2. -1/4 and -4. So that's going to be right there. And you can see the shape is kind of forming, and actually it's not going to hit either the y-axis or the x-axis. And you can imagine here if you had -4 as an input, you'd have -1/4 as an output. So your point would be here, and if you wanted to plot that, you actually could do that to help you see the shape a little bit. -1/3 would be like right there maybe. The next part, the positive part, 1/4 and 4 would be here. 1/2 and 2 would be there. 1/1 here, and 2 1/2 would be here. And the next one would be 3 would be 1/3, 4 would be 1/4, and so on and so forth. So you can plot as many points as you need to kind of help see the shape. Generally I do only about 5 or 6, but with this rational function you need to first of all catch this negative side here, this other side of the graph. And second of all, it kind of helps to plot a few more points. So this curve, if you have 4 or 5 points, it becomes easy to draw here, and also 4 or 5 points on this curve. So we can try to draw this thing. It's going to get real close to the axes here, but not cross them. It's not possible for the parent function to cross either one of the axes. So we'll try to draw this one right through these dots. And you see how if you have some more dots, it kind of makes it a little bit easier. It's not perfect, but it's pretty darn close. Some important points here, 1, 1, and -1, -1. And you can see that if you graphed the line y is equal to x, so right through the middle of this thing, right here, let's see here, how about right there? There you go. That this function would be symmetric over that line. So this function does exhibit some symmetry. It has both rotational symmetry, so if you rotated it 180 degrees it would be on itself. We call that point symmetry around the origin. This is an odd function as well. Or the line y is equal to x. If you flip that graph over, it would lie right on itself also.